Hello, in this video we're going to look at direct and inverse proportion, and as usual we're going to start with the key points. So first of all, it's important to realise that two quantities are in direct proportion when one quantity increases and the other increases at the same rate, so that their ratio always remains the same. And when you have that, you have a graph that looks like this, and it would be a straight line passing through the origin. And the reason for that is because it would have the form y equals kx. You're probably familiar with the fact that when you're told that two variables are directly proportional to each other, you can write that as one variable is directly proportional to the other variable, and you can replace this directly proportional symbol with an equality sign when you introduce a constant of proportionality. And you can see here that there's no y-intercept, so it would be a straight line passing through the origin. It's important to realise alongside that a graph like this, therefore, or like this, would not show direct proportionality because they don't pass through the origin. And so if you double one value, you don't double the other. For example, here we've got coordinates, maybe something like 0, 5. If I double the 5 to 10 up here somewhere and read off the graph, I'm clearly not going to get 0 for the x coordinate. So doubling one doesn't double the other. Okay, so if it's directly proportional, then a graph of the two variables would be a straight line passing through the origin. Okay, and then on to inverse proportion. So if one doubles, the other one halves. If one triples, the other one is a third, and so on. And that's what inverse proportionality means. So one's increasing at the same rate as the other one is decreasing. And in that case, we write y is inversely proportional to x, or one variable is inversely proportional to the other. And that means the same as one being directly proportional to the reciprocal of the other. Okay, so y is inversely proportional to x would be the same as saying that y is directly proportional to the reciprocal of x, which is what this statement says. And then applying what we've learnt in this key point here, we know that we can change this direct proportion symbol that we've got here into a constant of proportionality. That's because you're really saying the same as y equals k multiplied by 1 over x. That would be exactly the same process here if we did that here. And then, of course, k is the same as k over 1. And if you multiply the numerators and denominators, you get k over x, which is then exactly the same as what you have here. Okay, so they're very similar to each other. And importantly, it's useful to realise that when there's inverse proportionality, then you get a graph that's similar to the graph of y equals 1 over x, a reciprocal graph. And if you think about that in terms of transformations of graphs, y equals k over x is the same as y equals k over 1 times 1 over x. So if I started with y equals 1 over x as my function of x, then this would just be kf of x, which is a stretch parallel to the y-axis. So you would stretch out this graph by a scale factor, and so it would always retain the same shape as this graph here, 1 over x, but with the scale factor of enlargement. Okay, so that's the key points. Let's just get rid of those. And we'll go straight into some examples, and hopefully these examples will be consistent with what you've seen at GCSE. So we're told that y is directly proportional to x. I'm going to write that straight away mathematically. And as soon as I've written that, because I know I can replace that proportionality sign with an equality sign, I will do that. And that means I need a constant of proportionality. So y is equal to kx. And then they tell me that 16 is the y value when 5 is the x value. So I'm substituting there. And there. And so this tells me that k is 16/5 because I can divide both sides by 5. And of course k is a constant, that's what k stands for, a constant of proportionality. So now we know that in all cases where we're talking about the variables x and y in this question, the value of k is 16/5. So we can now say that when y is 30, 30 is equal to 16/5 times x. So I can multiply both sides by 5. And I get 150 equals 16x. And then divide both sides by 16. And I get 150 divided by 16 equals x. And I can obviously simplify that. Just go up here. So I can halve the numerator and the denominator. That'll get me 75/8 equals x, and I'll stop there. Okay, and then part B. Sketch the graph of the formula. So we can see from the formula, which was y equals 16/5 x. That's a little bit steeper than the graph of y equals 3x. So I'll draw a graph with a straight line with a positive gradient passing through the origin. And that is sufficient for my sketch because normally we would indicate the x and y intercepts of a graph on a sketch, and obviously this graph passes through the origin. Okay, on to example number 2. So this time we've got direct proportionality to x squared, not to x. So again, we'll start by just writing that mathematically and then changing our proportionality symbol to an equality symbol. And now I'm going to use the information in the question. So when x is 3, y is 45, and that is me substituting in here and here. So that's 9k equals 45. So dividing both sides by 9, we get 5 equals k. So y is 5x squared. And now we can go on to completing part A. So when x equals 5, y equals 5 multiplied by 5 squared, which is 125. And part B, I'll go up to the top here. So this time they tell us y equals 20 and they want us to work out what x is. So we know that 20 will be 5x squared. So I can divide both sides by 5. Give me 4 equals x squared. Now remember, you could take this positive and negative square root of both sides here, but you'll remember that I much prefer when it's quadratic to making sure that one side ends up being 0. And then factorising if possible. So in this case I would factorise using the difference of 2 squares. And that gives me that x is -2 or +2. And the reason for that, why I prefer that method, is that if you were to square root both sides of this equation, it's very common for students to forget the negative square root and only get one solution where x is 2. Whereas you can see here by factorising, you get 2 solutions. Okay, so that's example 2 done. On to example 3. So this is our only example of inverse proportion. So again, inverse proportion to Q is the same as direct proportion to the reciprocal of Q. And so that means that I can replace my direct proportionality with a constant of proportionality. by writing it with an equality sign. And they tell us in the question that when P is 100, Q is 10. That's just a substitution in there of Q and in there of P. So if I multiply both sides by 10, then I get K is 1000. So that tells me that P is 1000 over Q. And now we can go on to finding Q when P equals 20. So I'll multiply both sides by Q. Divide both sides by 20. Go up to the top here. So Q is 1000 over 20, which is 100 over 2, which is 50. Okay, so that completes the examples for proportion. So hopefully you can now attempt the practice questions on proportion on the document.